Okay, so we have here sample problem 2. So we are asked to calculate the runtime active force per unit length of wall, and we are also asked to solve for the location of the resultant from the bottom. So the given retaining wall has a length of 15 feet. We also have here the cohesion that is equal to 0. So our backfill is sand. We also have here the unit weight that is equal to 105 pounds per cubic feet. And our angle of internal friction is equal to 30 degrees. So in our problem, we have no groundwater. So there's no given location of groundwater table. So we will assume that the unit weight of our uh, backfill is in dry condition. So for us to determine the runtime active forces, it will be easier for us to calculate the corresponding values by drawing our pressure distribution diagram. So in this case, our pressure here at the ground surface, H is equal to 0. Yung pressure natin dito is 0. And increasing with the depth, so wala tayong groundwater table. So increasing with the depth, we have a pressure at 15 feet. Okay? So we have a pressure of P sub A multiplied by unit weight multiplied by our H. And our resultant P is located at 1/3 of our height from the bottom. That is the centroid of triangular shape. Okay? So, at H is equal to 0, our pressure is 0. And the distribution will be increasing as the depth increases. So, the uh, active pressure at 15 feet is equal to this equation. So we have given equation. So that will be equal to the active lateral earth pressure, yung K sub A natin, multiplied by our unit weight times height. And this unit weight times height is our overburden pressure. Okay? So let's begin by solving for our K sub A. Our active lateral earth pressure coefficient. And for the K sub A, we have an equation that is 1 minus sine of our angle of internal friction over 1 plus sine of P prime. So substituting our values, that is 1 minus sine of 30 and 1 plus sine of 30. So our K sub A, the our coefficient of lateral pressure is equal to 1/3. So our K sub A is equal to 1/3. Okay, we have now our K sub A. Let's now solve for our active pressure. So based on this stress diagram or our pressure distribution diagram, at H is equal to 0, we can say that our active pressure is equal to 0. And at H is equal to 15 feet, let us solve for our pressure. So that is equal to pressure at 15 feet is equal to this equation. So we have K sub A multiplied by the unit weight times the uh, height. So this is actually the effective stress, yung overbearing pressure natin. Effective yung kinukuha natin, yung unit weight times height. That will be equal to, that is 1/3. Our unit weight is 105 pounds per feet cube. Our H is equal to 15 feet. So our pressure at 15 feet is equal to 525 pounds per feet square. Okay. Magka-cancel yung feet dito and feet dito. So magiging square na yung feet. So our pressure at 15 feet is equal to 525 pounds per feet squared. Okay? So let's now solve our active pressure, which is our PA. That is our resultant active pressure. Okay, so our PA now is equal to 1/2 of our pressure at 15 feet times our height. That is the area of this triangle. Okay, so we have our active pressure at 15 feet times our height. Okay, substituting the values, so we have 15 feet squared and then our height is 15 feet. So cancel yung feet, magiging feet na lang yan. So yung magiging active force natin ngayon, yung resulting active force per unit length is equal to, that is equal to 3937.5 pounds per feet. Okay, that is now our Rankine active force per unit length of wall. So PA, since we're talking about the active force. So this will be now our answer for letter A. So what about for the letter B? So for the location of our active force per unit length. So yung location ng PA natin is the 1/3 of height, since this is from the bottom. That is the centroid, where the centroid of our resultant nung ating triangle na diagram. So let's say the location of PA, so let's say so Z is equal to 1/3 of our height. That is equal to 1/3 of 15 feet. Our resultant from the bottom is equal to 5 feet. Okay. Have here the problem number 3. This is actually the same with our problem number 2. However, yung problem number 2 natin active. This time, yung problem natin is in passive. So we assume the retaining wall shown in the figure we have here is frictionless. So we have to determine the Rankine passive force per unit length of wall, and we also have to determine the location of the resultant from the bottom. So this is actually the same with the previous problem. At ang kaibahan lang, yung previous problem natin, number 2 is in active. Ito in passive. Okay? So, let's begin by solving our coefficient K sub P. Yung lateral earth pressure coefficient natin in passive. It is given by this equation, 1 plus sine phi squared over 1 minus sine phi squared. So, substituting our value here and solving, makukuha natin, K sub P natin is equal to 5.37. Okay? And for our passive pressure, so let's say at H is equal to 0, our uh, passive pressure at H is equal to 0 is equal to 0. And then at H is equal to 8 feet, our passive pressure at 8 feet is equal to K sub P times the unit weight times the height. So substituting our values here, so we have K sub P, we have the unit weight, and we have our H, which is 8 feet. Okay? So at H is equal to 0, our pressure now is equal to, passive pressure is equal to 3112.56. So kindly check if my calculation is correct. That is in pounds per feet squared. Okay, so we have now the values, so we can now draw our pressure. So we have 0 here, and then we have a value here which is equal to this value, that is 3112.56. Okay? So our Rankine passive force per unit length of the wall, so yan is yung ating resultant here. Let's say that is our PP. So solving for letter A, yung PP natin, that is equal to yung resultant ng ating triangular na distribution. So that is equal to 1/2 yung value natin dito, yung sa pressure, times yung height. So we have PP is equal to 1/2. The value is 3112.56 times our height, which is equal to 8 feet. So this is in pounds per feet squared. So our runtime passive force per unit length of the wall now is equal to 450.24 pounds per feet. So kindly check if this my calculation is correct. So that will be now our answer for letter A. And for letter B, for the location of the resultant, so the same, since this is in a triangular shape, our centroid for triangle is h over 3, yeah, from the bottom. So for our location, say that is C, that is h over 3. And substituting our values, that is 8 over 3, our Z now, or our location, or our resultant from the bottom is equal to 2.67 in feet. So our H is in feet. So this will be now our answer for letter B. Okay?